Assalamualaikum and good morning. Today I'm chapter 7, bolted and welded steel connection without eccentricity. Types of connections. Connection are needed to join member together in trusses and lattice girders. Let's say you ever look at any steel design kan, dia macam like 3D. Dia ada macam ni, and then dia ada macam ni, and then dia panjang lah. Something like this. So you nampak dia macam ada bersilang-silang besi. So inilah contohnya lattice girder lah. Lattice girder can be in many design. Macam-macam design dia ada. So dia ada sambungan-sambungan lagi. Ini sambungan ni daripada one member to another one member. Dia akan pakai, because of this is a steel elements, dia akan pakai steel connections. Plates together to form a build-up member. So you have plates. Mungkin you nak combine with I-beam. So you have I-beam lah. You will use steel connections. Beam to beams, trusses, bracing, etc. and columns in structural frame. So you now combine between all these elements and columns to foundations. This one, let's say column, it is steel column, and then you have a foundation. Can be steel foundation also kan, because of your other steel footing also. You boleh combine dengan menggunakan steel connections. This is contohnya lah. So internal truss joints, you have like trusses yang you nak joins together between like one plates and all the elements of truss yang lain-lain ya. We have brackets, beam connection, because you want to connect between this I-beam on one side and the other side of beam yang lain, you nak connect together as a column base. The ordinary bolt, the black hexagon head bolt shown with nut and washer is the most commonly used structural fastener. The bolts are into strength grade as specified in BS 4190. This area we call it as shank. This is the thread. Tensile area will be at the thread area. The nominal diameter kita akan tengok pada shank. So mostly kalau dia kata size of bolt tu adalah size shank ni lah, maksudnya diameter shank ni berapa, itulah nominal diameter dia. The length is daripada atas shank sampai hujung thread. Since tadi I cakap dia ada dua grade, which is grade mild steel and high tensile steel. Kalau mild steel, the yield stress is 235, meaning dia boleh support as much as 235, and if it is high strength steel, it can support as much as 627 Newton over mm square. The main diameter used are so 16, 20, 22, 27. However, size yang dalam bracket ni is not preferred. The nominal diameter of hole for ordinary are greater than the bolts. Dia punya hole mesti bigger than the diameter of the bolts. Let's say sampai up to 22 mm, maksudnya daripada 16, 20, 22 ni, you tambah 2 mm untuk diameter dia. For example, kalau 16 mm diameter bolts, hole dia akan jadi 18 mm. Because of you tambah another 2 mm. Kalau 22 mm diameter bolts, hole become 22. If 22 mm diameter bolts, the hole become 24. But up to 22 saja. So start daripada 24, you kena add another 3 mm. Let's say 24 mm diameter bolts, so hole dia akan jadi 27 mm. You kena tambah 3 mm. If 27, then jadi 30 hole. And if 30 mm diameter bolts become 33 mm diameter hole. Bolt may be arranged to act in single or double shear as shown in the figure. This is single shear. For example, you have two plates that you want to combine together. You akan letak bolts dekat dalam ni lah. So this is the hole. This is side views. Ni plan views. Tengok dari atas macam ni lah. This is like cross section lah. For example, you cut here. So this is the cross section dia. And same goes with the double shears. Double shear, if you look at here, yang mana satu sebenarnya yang you nak combine. Ini dua-dua ni adalah member plate. So this one we call it the one yang kita nak connect together, we call it as member plate. Same here, if you look at ni macam sandwich. Yang dekat tengah ni, 1 dan 2, this is member plate. However, the one yang at top and bottom, this one we call it cover plate ataupun splice plate, SPLIC. Kegunaan cover plate atau splice plate ni sebenarnya you just nak boltkan dia together so that these two member will combine. Ini kita panggil dia double shear, and this one is single shear. This is sama jugalah. This is plan view and this one is the cross section views. For example, you cut it here. Daripada depan you akan nampak. So you nampak macam ni. This is the whole hole. Spacing akan daripada centroid bolt yang you letak ni ke centroid yang sebelah dia. And distance daripada centroid of this bolt yang paling hujung ke hujungnya lah. Edge distance yang this one daripada centroid to the end here. This is edge distance and distance spacing. When you design, you kena tahulah. Provision for spacing edge and end distance in normal conditions are. The minimum spacing is 2.5 times the bolt diameter. I buat example lah. You have a bolt that size is 20 mm. Minimum spacing kita tengok balik spacing yang mana daripada centroid first bolt sampai centroid the bolt next to it. Minimum dia tak boleh kurang lagi pada value ni. Spacing should be 2.5 darab dengan diameter of bolt. 25 times 20 you akan dapat 50 mm. Spacing tak boleh rendah pada 50 mm. If letak 45 mm, so tak boleh. Mesti at least 50 mm. The maximum spacing in unstiffened plates in the direction is stressed at 14 T, where T is the thickness of the thinner plate connected. For example, the thickness of plate T adalah 25 mm. Senang cerita, for example, it is ada double shear. So contohnya, this is double shear. Ini ini 25, satu lagi 30. You akan ambil the thinner plate connected. 25 adalah yang paling rendah. Maximum spacing should be 14 times 25 mm. Spacing you mesti antara 50 mm ke 350 mm. You can put any number between this lah. And then you have another one, the minimum edge. The minimum edge and end distance from a roll machine flame cut or plain edge is 1.25 D, where D is a hole diameter. Kita pakai data yang sama. For example, diameter bolt adalah 20 mm. Hole will be 20 mm plus dengan 2 mm. This one it says that when it is 16 sampai 22, kita kena tambah 2 mm for diameter of hole. That's why plus 2 mm. So it become 22 mm. 1.25 darab dengan 22 mm. 27.5 mm. This is the minimum edge distance. The other one is the maximum edge distance is 11 T constant, where constant is 275 PY. Sekarang ni kita tengah buat untuk plate kan, where constant, so PY ni steel strength. Ini mesti steel strength untuk plate, bukannya steel strength untuk bolt. For example PY is 155. Take the constant equal to the formula of 275 divide by PY and use square root. Then you will get 1.332. Next, we're going to use the formula of maximum edge distance, 11 TE. T, again, we use the similar one as the example that I put here. T is 25, so 11 times 25 mm, and you just times the value of the constant, 366.3. The minimum edge distance and also the maximum edge distance is between 27.5 to 366.3. So it shouldn't go below the 27.5 and it shouldn't exceed 366.3. This is how you're going to calculate the spacing, edge and end distance. A shear joint can fail in following 4 ways. There are 4 shear joint failures: by shearing on bolt shank, by bearing on the member or bolts, by tension in the member, and by shear at the end of the member. So going to look at one by one. The first one, which is by shear on the bolt shank. So shearing on a bolt shank, what happened here, you see the bolt is breaking into 3 pieces lah, senang cerita. So bolts ni pecah, so because of there's a force that pulling this plate, and here also pull it out. And in single shear also is about the same lah. See that there is a break between the bolts. Why this happen? Basically, for mode 1, shearing of bolt shank, provide sufficient bolts of suitable diameters. Because of the diameter is not suitable, maybe the diameter is too small, this caused the bolt to break into pieces. And the second one, we have bearing on plate and bolt. Bearing on plate and bolt is also the same because you didn't provide suitable diameter of bolt For example, here kalau steel connection you have bolts and then you ada hole here. If you didn't provide, mungkin dia terlampau besar, maybe the bolt size is bigger and you don't provide the suitable diameter of hole for the plate, what will happen when there's a force that acting on this, sebab dia terlampau besar, is not suitable for the hole, so dia akan tarik. Or perhaps when it is too small, bolts tu dia free to go left and right and up and down, because there is a space that doesn't fit the hole, so dia pun lebih senang bergerak, and when there's a force pulling it out, the bolt will akan tarik sekali the plate. Bolts ni yang akan crush, pecah. And the third one we have here is design tension members for the effective areas. Tension failure on the plate. What happened here? The bukan bolt yang pecah, but plate ni yang break into two. Probably because the plate don't have enough strength to resist the force that pulling it out. Because of here, it says that for mode 3, design tension members for the effective areas. For the effective area, this one, supposedly the effective area is that this place lah. When there is a force and you don't provide enough strength for the steel to resist the force, steel you akan pecah between these two. And also if you don't provide enough thickness because of shearing, is affected by the thickness of this plate. Area dia tak cukup, strength dia tak cukup. Why? Because of the area to maintain the same form. This is the plate. This area yang actually resist the force. Okay, because dia nak maintain the same shape so that dia tak break into two. This area is not enough, because kalau you cut it, this two, so this area you provide is not enough. Maybe you thicken the plate, perhaps it will provide better resistance from the force. And last but not least is end shear failure. This is number 4. You have to provide sufficient end distance for mode number 4. You don't provide enough sufficient end distance for the design. What happened here? Mungkin tak cukup. Probably maybe you should provide around 100 mm perhaps, but then you only provide 60 mm. The bolts will tarik sekali all this, so you punya plate akan pecah lah like this. I'm going to stop here for the theoretical part. We will continue during the next class.